Hey everybody, we are taking a look at the histology of the cochlea, C-O-C-H-L-E-A. The cochlea is the inner ear organ for hearing. There's another inner ear organ for vestibular sense. We'll get to that later, but this is for hearing. So we're at 40x right now. We see a repeating pattern of these ducts. We see this large one, this small one here, and then a medium-sized one. Large one, middle, blah. They come in threes. 1, 2, 3, 1, 2, 3. So these ducts are, if you can imagine this, they're spirals. So we're spiraling around and around like a snail. The cochlea looks like a snail. And because we've made this cut, through it, we're seeing the inside. So we see these ducts that are spiraling around and around. The larger of the ducts on the bottom, that's called scala tympani, the tympanic duct. Scala means duct. Scala tympani, the one in the middle is media, scala media. The one on top is scala vestibuli. So vestibuli, sorry about the focusing, try to get it right here. It goes vestibuli, media, tympani. Let's go a little closer. Let's go to 100x. Okay. This is scala tympani, vestibuli, media, tympani. And this repeats. Vestibuli, media, and tympani. Vestibuli, media, tympani. How do I know which one's which? Like, how do I know it's not flipped? What I'm looking for, let's stick with this one. Look for this. When you have the division between media and the others, so media should be easier to recognize. On one side of media, you've got a thin border, right here, and the other side, you've got a very thick border. Where you have the diagonal thin border, that's called the vestibular membrane, and so it's separating scala vestibuli from media. So this is vestibuli, this is media, this is tympani. Scala media is functionally the most important. We'll get to that last. Scala vestibuli and tympani, they are the first, or I should back up. Scala vestibuli, the top one, scala vestibuli is the first one to receive the pressure waves when the malleus, incus, and stapes vibrate. So when you hear something, your tympanic membrane vibrates, then it vibrates the auditory ossicles, malleus, incus, and stapes, and then the stapes vibrates the oval window of the cochlea. When the oval window of the cochlea vibrates, that then vibrates the perilymph. It's called perilymph, the fluid inside of the cochlea. The perilymph vibrates, and you have these waves flowing through. And it's the waves that are inside, the fluid waves inside of scala vestibuli that then vibrate, which also is vibrating the fluid inside of scala media. And then that vibration needs to exit out somewhere, and so now you have a fluid wave exiting out through scala tympani. Because in reality, scala vestibuli and tympani are actually all connected. It's just connected at a single point. It's easier if I could unroll this for you, but we just have a slice to work with. So this space is fluid filled. This is where you'd find perilymph. Perilymph in scala vestibuli, perilymph in scala tympani. Inside of scala media, you'd find endolymph. In here, you'd find endolymph. Again, the dividing point between media and vestibuli, this is the vestibular membrane, dividing scala media from tympani. This is the basilar membrane. It's at the base, basilar membrane. Let's go a little bit closer now. Going to 400x. Okay. Once again, let me get my bearings here. Okay, this is scala media. Up here is tympani, vestibuli, media, tympani. This whole area here, and let me go back out one more time, it'll be easier to see. This whole area here of cells, this collection of cells, where I'm trying to trace right now, so it's found within scala media. This region of cells here, this is the organ of corti, or the spiral organ. This is the true organ of hearing, the organ of corti. This is where we have our sensory receptor cells. So let's go a little closer so we can see them better. These cells that you see here, like what I'm pointing at here, these are called hair cells. They're called hair cells not because they produce hair. They're called hair cells because they have stereocilia. Stereocilia are found on the apical side. I'll go over here. And stereocilia bend in response to those fluid waves, those pressure waves. And pressure waves are caused by sound, or they can be caused by sound. And so that's what allows us to hear. Hair cells are special receptor cells. Sorry, I'm going to try to fix this. Hair cells are special receptor cells. And when they get activated, there we go. And when they get activated, they then activate a sensory neuron that relays along, it forms the cochlear branch of the vestibular cochlear nerve, cranial nerve number 8. And so these receptor cells, hair cells, you've got your, which way is the neuron? The neurons will exit this way. So these are a little easier if I zoom back out. We're at 100x. The cochlear branch of the vestibular cochlear nerve are going up right here. You can see, and also out here. All these are axons. So this is cranial nerve number 8, the cochlear branch of cranial nerve number 8. You can see cell bodies here. These are the cell bodies of the sensory neurons. So this is a ganglion. This is a cochlear ganglion of these bipolar cells. Whoops, sorry. So yeah, here's a ganglion, sensory neurons. The sensory neurons receive input from these hair cells. So I'll trace this one more time. We're in scala media here. This is scala media. Here are the hair cells. Here's the basilar membrane. But these hair cells communicate with a sensory neuron that extends out. Here are their cell bodies, and they keep going. The axons keep going. What you see here, this is bone. It's the temporal bone. The cochlea is protected by the temporal bone. So the hair cells, the stereocilia, they don't move themselves. Again, they're moved by pressure waves, but more than that, they're moved by something that's on top of the stereocilia. This membrane right here would be in a normal, physiological thing. This thing would be on top of the stereocilia. This thing is called the tectorial membrane. If you've heard the term tectonics, like if there's an earthquake, there are tectonic plates that move, the tectorial membrane shifts around with these pressure waves. So the tectorial membrane shifts, it moves the stereocilia of the hair cells. Hair cells down here. Hair cells get activated. Hair cells then communicate with sensory neurons. Here's the cell bodies of the sensory neurons, and the sensory neurons relay. Their axons form the cochlear branch of the vestibular cochlear nerve, going to the medulla, onto the thalamus, to the auditory cortex in the temporal lobe. That is what we can see here in this histology of the cochlea. And whether I show you on this set of ducts or the other next one or the next one, it's the same exact thing. It just repeats over and over. Thanks. Let me know if you have questions. See y'all later.